Ladies and gentlemen, this is Sunny Surlekar, Head of Technical Services at SS Buildchem and Director of IITD. Today we are here to discuss some solutions for sustainable construction, and what we'll be talking about in brief would be green concrete, modern formwork, and thermal coating, and how all these systems come together to make construction better, more durable, more energy efficient, and sustainable. Further on this presentation with me was inputs by Engineer Paresh Unarkar, one of the very well-known concrete technologists as well as structural engineers in Mumbai, as well as we were mentored by Mr. Sunny Surlekar, who's director of SS Buildcare. So with that, let's get started with our agenda for today. We'll talk a little bit about introducing the concept to you along with the construction system, like how the whole concept came about and how it works. We'll talk a little bit about green concrete in itself. We'll talk a bit about thermal barrier coating, on how the coating functions, what's its application, how it's used, and so on. And finally, we'll talk about what are the practical applications, what did we see, and what we can do with it. So, firstly, talking about sustainability as a whole, the aim of sustainable construction is to reduce both the environmental as well as the financial impact over life cycle of the structure. That means right from the time the materials are selected, the construction is going on, construction is completed, it's occupied, it's in use, in service, for repair and maintenance, and finally at demolition. So it should add value, or it should rather reduce the impact over this entire life cycle. And that's when we can say that construction is sustainable. So our modern sustainable construction model is based on three basic tenets. So the first one looks at formwork. So using the most modern, most well-known aluminum formworks that are available, designing concrete that is absolutely green with reduced footprint, and using thermal barrier coatings which behave both as insulation and waterproof. So a little bit about the aluminum formwork system. I mean, this has been very popular in cities, especially cities like Mumbai. So the advantages include very rapid erection progress, and the main thing it does is it eliminates block work plaster. So your construction is much faster and the durability is much better. The water tightness is there, the loads are lesser. So overall it adds a lot of benefits to it. So although the formwork system in itself may be a bit more expensive, but over the construction cycle and its reusability, it actually reduces a lot of the financial impact. Now, green concrete is something concrete that is much more sustainable, I would say. So, what we're looking to do is reduce the carbon dioxide footprint of the material by replacing a lot of the OPC with GGPFS. That, of course, leads to much better durability, much more water tightness, and of course, savings in the cost of the cement itself. And overall, because of its kind of durability and the reduced CO2 footprint, the material becomes both very, very cost effective to make as well as very, very sustainable in the long run. The last one is what we call as a thermal barrier coating. So this is material that looks like paint, it's applied like paint, feels like paint, but actually behaves like insulation. So that means it accounts for very large reductions in temperature, or like in case of cold countries, it helps to warm up the structure. And it's based on advanced modern binders and nanoceramic technologies. So overall, in a place like India, what we're looking to do is have 20 to 30% reduction in temperatures, which further, of course, leads to savings in electricity bills and so on. So the core idea is, of course, to increase the durability of the structure by lowering its permeability, lowering the RCPT values. We're looking to reduce the CO2 footprint because we are doing this by optimizing the OPC content and using local materials for making the concrete. Of course, with this whole exercise, we found that we are saving a lot of cost because of the cost of the materials involved, and the kind of construction system, because of the fast aluminum formwork system, it is much faster to construct and much cheaper in the long run because of the reuse of it. Last but not least, of course, we make it sustainable by saving energy and lowering the cooling costs. So, talking a little bit about the green concrete technology, the concept came about, like, it started off with making this concrete at a batching plant on site. What was targeted was to make concrete which is M30 or M35 in grade. The substitution of OPC was targeted to be 50% or more, a reasonable workability time of about 90 minutes. Of course, admixtures were used both to reduce water, improve durability, improve the flow, and so on. And this led to a new idea, like, could we batch the SCC at site? And the reference for this, of course, came through Unarkar's green concrete technology. That's the name of the firm at Virar. So from there, the first step that was taken was to see, okay, how does the concrete perform on its own? So basically, a fixed a water content or a water cement ratio was fixed. So we used basically 390 kgs of the binder, 233 kgs of water. So water cement ratio somewhere a little bit more than zero point 0.5. There was no admixtures used to in the initial study. What we worked a lot on was using local sands and local aggregates to create an aggregate skeleton. That means we knew exactly what blends to make so as to do this, and only the quantity of this aggregate skeleton was varied for the concrete mix in general based on volumetric requirements. So we tested OPC, PPC, then OPC and fly ash, OPC GGBFS, and OPC and silica fume in different combinations. And it was tested for things like workability, slump at 30 minutes, at initial 30 minutes, 60 minutes, compressive strength up to 56 days, then the water permeability, water absorption, RCPT, and so on. Not go much into the results themselves. But what we essentially saw was that even with the GGBFS mixes, the workability, of course, of those mixes was much better as compared to OPC only. The compressive strength was very comparable. The water permeability values were very comparable. But what surprised us was that the RCPT values were much lower. So that means the durability aspect of the concrete itself becomes much more interesting. The cost per cubic meter at 3838 to batch on site was almost about 450 rupees cheaper as compared to full OPC mix. And this, of course, this kind of mix, we put it into practice. So it has been used at multiple sites in and across the northern Mumbai region. We've used it for an industrial complex, a high 21-story tower building. We're using it for a school building. By far, you can pretty much see how the finishing and everything looks. It's done beautifully. The quality is controlled. And at site, in terms of quality, we actually did a lot of pouring, and we did a cross verification of it. And the concrete was pretty much showing consistent cube strengths of almost about 42 Newton per mm squares. So it was quite a good thing. Of course, we took the codes, we tested the codes, and it is correlated to the cube strength. So overall, the performance was seen to be pretty consistent, and the durability pretty good. So overall, we saved almost 50% of cement per cubic meter, which is almost about 200 kgs of OPC. The strengths were consistently good, over 40 MPa, so strength was not a big criteria. Over 3,000 metric tons of carbon dioxide was reduced because that was the volume of cement which we did not use. And all in all, including the cost of admixtures, we ended up saving almost about 250 rupees per kg, per cubic meter. So the next part was that could we make SCC out of it? So we put together a mix with the modern admixtures like PC. So we're using the best of all the materials, the My1 formwork with the PCE. So we are using the best of all the materials, and even with the PC, a bit of customization was needed. So water reduction, the cohesion, the slump retention, stickiness, a lot of these different kind of aspects, the strength gain part of it, and as well, and the flow, of course. So all these had to be taken care of, and that is what we kind of did with the admixture. So of course we created the aggregate skeleton according to the maximum using a maximum density curve. So we went a little bit on the finer side so that the flow and all the flow properties can be maintained. And yes, we were successful. So a lot of trials, I think we casted over or made over about 15 to 16 different mixes, and finally we could actually achieve SCC. So we did make the mix that met the requirements of flow, that met the T500 time, the V funnel time. It passed through beautifully through the J ring, and what we saw that in terms of compressive strength and everything, the mix behaved absolutely beautifully. So you're getting almost close to 56 to 60 newtons on an average in compressive strength. And even though it was SCC, even though it used a stabilizer, it used a PCE, we were still saving a lot of money as opposed to an OPC mix, like almost about 230 rupees a cubic meter. So that's how we can put to use good green concrete. And from there, we go to a thermal barrier coating. So basically, what a coating like this does is that you simply coat it onto your structure, and it helps you maintain comfortable living environments. It reduces your energy cost for heating or for cooling. And last but not least, it creates a waterproof barrier. So because of this, what we're looking to do is save energy over time, save money, and of course save time in the application as well. Because insulation is quite a difficult thing to do. So if you can do it simply like a coating, you're saving a lot of time. So in simple terms, if you're looking at a structure without thermal barrier coating, The temperatures normally seen are say about 31 to 46 degrees depending on summer winter variations, and most of the heat is absorbed by the building. But in the case that you're using a thermal barrier coating, most of the heat is reflected and emitted by the coating itself, and it allows very little heat to permeate through the building, in which case your temperatures in practice were seen down to 21 to 26 degrees depending on seasonal variation. So how this material works is basically on the concept of like it basically reflects the heat, like most of the heat is reflected directly from the surface of the coating, and also it has got a very high thermal emittance, which means whatever is the balance of the heat is kind of absorbed away from your coating. So basically, very little of the heat, like hardly about two to 2.5% of the heat actually enters your structure, and it remains much cooler in the long run. This kind of a coating, of course, it works better if you do it both inside and out. You can do it over your plaster, you can do it over your gypsum, brickwork, blockwork, whatever it is. So what it does is it protects your structure against thermal gain, and it also protects it against water and weather. And the secret to this is the ceramics. So the binders, of course, is a very interesting matter, subject topic in itself. But the key ingredient in that is the ceramic part of it. So just to see it like in terms of a test, what we did was a simple, we call it as a griddle test. So we just take a griddle, we heat it up. So you can see that from the coating side, it is about 75 degrees, and on the uncoated side, it's going up almost up to 175 degrees. So that's a quite a lot of heat to be reduced. This is of course not in a building condition. A building will never get heated to those kind of temperatures, but it pretty much gives you an idea of the efficiency of these kind of coatings. Means even at high temperatures, it really reduces close to about 100 degrees of the 100 degrees of the temperature, and this is simply because of ceramics, because it addresses all different modes of heat transfer and is very efficient at reflecting the heat back to the source. Of course, this kind of a thing, since it works as insulation, it also works very well after the coating gets dirty. So all in all, it's a pretty interesting product to see, because one is it looks and feels like paint. So it's low in VOC. Of course, it provides an insulation. It's waterproof by default. The weathering properties or the UV properties are very good. It's resistant to chloride and carbonation. Green, saves money, and overall improves the efficiency of your systems. And this kind of material is available in India at the moment. We have tested it. We have tested it in depth at IIT for physical properties and at SEP for the insulation properties. And you can see very well that the application of this kind of material is very easy. So it looks, feels pretty much like paint. So you apply it with the standard spray gun. Voila, it's easy to apply. You prepare your surface, apply the coating. It's as simple as that. No complicated methods, no PUF, no finishing, messy materials, nothing. So it's a very easy to do things, and so it really helps. So the next idea we saw was how we could bring all these three concepts together on a PMAY, that is a Awas Yojana project, which is like a low cost housing. So the total built up area was about 47 lakh or 4.7 million square feet. But the total area of one building was roughly about 28,000 square feet. So we did a total cost comparison, like what would a conventional building entail, and say using this SCC formwork, the SCC formwork and the thermal coating system, what it would entail. And we kind of made a cost comparison between the two. So what would be the basic cost of construction? So even considering all the different heads, we actually found out that the building made with the modern formwork, made with self-compacting concrete, made with high-grade PCs, high-grade thermal barrier coatings, and everything. The total cost per square feet worked out almost 22 rupees per square feet cheaper than the conventional method of construction. So what this meant, or in terms of this one, in terms of savings, was that we saved almost close to 6.3 lakh rupees per building, and which meant that over the cost of the entire project, over 10.75 crore rupees could be saved. That's quite a lot. It's almost close to 100 million rupees. So all this with the benefits of high durability, lower maintenance, reduced carbon footprint. It is much faster to construct, savings in electricity, and lower capital cost. That means lower cost of initial cost of construction. So all these kind of things makes it very interesting, because this kind of a concept is applicable to mass housing, which India desperately needs at this point in time. We are doing it in a very eco-friendly way. We are addressing both environmental as well as the durability concerns in the concrete. We can meet most, I would say, strength requirements. So like even designing 50 newtons, 60 newtons, 70 newtons is not going to be a problem. with the right aggregates, with the local aggregates, so we are not very choosy about where the materials comes from. The thermal barrier coating, of course, it functions both as insulation and waterproofing, so it saves both steps, provides a lot more benefits for a easy kind of material, and of course saves energy over life of the structures. So it's quite an interesting concept as a whole, which we feel can really help the Indian construction industry in the time to come, and hence we thought it prudent to share with you this concept. So once again, thank you very much for giving us the time for listening to a new concept. And of course, if you have any more questions about this, please feel free to write to us. We have my details on the screen, and you can just take a quick screenshot of this, so you can give us a call, and we'll definitely get back to you with the questions. Thank you very much.